Hi everybody, Patrick here from EngineeringShock.com and ElectronicLessons.com. This is video number 2 in the laser security system tutorial. I'm going to be trying to give you electronic bricks that you can use to build this yourself or variations of it. Now, right now, if you haven't seen the first video, this is just going to look like a hunk of junk. I've actually followed through in the first video, going through in detail, in theory and in lab, the circuit so far. But to reiterate, we've got a 9-volt power supply. We're regulating it down using a 7805 5-volt regulator. At the regulated 5-volt output, we've got two capacitors, 0.1 microfarad and 10 microfarad capacitors, just in case you're not using a battery as a supply, just to filter out ripple and high frequency interference. Down here we've got our LDR circuit, our voltage to voltage divider. It's variable depending on how much light is hitting the resistor. We've got a secondary divider set up to offer 500 millivolts to the negative input of a comparator. When there's more voltage as the positive input of the comparator than there's the negative, the output goes high. And if there's more voltage at the negative input of the comparator, the output stays low. So what I've done is I've actually removed the 470 ohm resistor and the LED, and I've added in right here what's called a monostable multi-vibrator circuit. And I use a 555 timer for that. And I'm actually going to disassemble what I've done here in this area of the circuit, and I'm going to show you how to build it piece by piece. And again, I'm going to show you a few different things that you can do with this circuit. I'm essentially using this as a base, and I'm going to be adding different ideas to the output. So I've got my laser connected to or pointed at and fixed at my LDR, my light dependent resistor, and I've placed my LDR at the output of my 555 timer. Now I've set this up to give me about a pulse of about 1 second. So when I break the beam, this LED should turn on for about 1 second, and then turn off. Let's do it again. And I can change that, how long that pulse width is, by varying two passive components, a resistor and a capacitor on the 555 timer. Very easy to do. So another thing I can do is I can put a buzzer at the output of the 555 timer, because the 555 timer can support more current than the LM324 op amp. So I can put a buzzer there instead of the LED. In fact, before I actually disassemble this and show you how I did it, I'm going to show you it with a buzzer, just so we can kind of get a security element in there. Someone breaks the laser and beep! So let's do that. So I've added a buzzer in series with ground right there. And again, there's my laser pointed at my LDR. So if I break it, about a 1 second long beep. Now, I can fix that. I can make it so that it beeps for much longer or shorter, for several seconds. Really, it's up to you, and I'm going to show you how to do that. So, first of all, I'm going to disassemble the board to the point where we just have the output of our comparator. Again, if you haven't watched the first video, it might be a little bit ambiguous. You might want to look back at my channel and check out this video, or the first video. But I'm going to add in the monostable multi-vibrator circuit right now. The 555 timer is an 8-pin dip chip. Actually, I shouldn't say it's a dip chip. By dip, I mean dual inline package. Good for breadboards. Could be there are 555 timers out there that are SOP, that are surface mount. But anyway, that aside, 8 pins. There's a notch on the left-hand side, and there's a notch on my schematic. So I'm just going to get that out of the way here. Now, there's a lot going on here. This is set up in monostable mode. 555 timers can oscillate for you. They can create pulses that are good for all sorts of test circuits and to make audio noises. But here what I've done is I've taken the output of our comparator and I've placed essentially a transistor switch. So if you're not familiar with transistors, and you might have a little bit of difficulty seeing what's going on here, there's a 2K resistor connected to the base of the resistor. This transistor is a 2N222. So just look that up. It's a very small, little 3-pin chip, TO20, I believe, or rather TO92. TO92. Anyway, so there's a collector, a base, and an emitter. So when a pulse is, since it's an NPN transistor, when a positive pulse hits the base through this 2K resistor, the voltage and current at the collector sinks all the way through to the emitter. Emitter is down here, E. So in which case we've actually got a 2K ohm resistor, pull-up resistor connected to pin 2. Pin 1 is the leftmost, pin 4, pin 1, 2, 3, 4, 5, 6, 7, 8. So you got 2K resistor connected to the 5-volt line down to pin 2. So there's 5 volts on pin 2. When the output of the comparator goes high, it activates the transistor and sinks the 5 volts to ground. And obviously we need to have that pull-up resistor there, because we can't just connect 5 volts to pin 2, and if we create a circuit, we'll be sinking 5 volts with no current limitation down to 0. So that 2K resistor is necessary because it's only sinking a little bit of current to ground. 5 volts divided by 2K is your current. Anyway, so what that does is that acts as a trigger. The second pin is a trigger pin. Pin 1, as you can see, is connected directly to ground. And pin 3 is our output, and that's connected in this case to a 470 ohm resistor and to an LED to ground. And I've actually just substituted, as you saw with the buzzer. Pin 4 is a reset pin. I like to put a power on reset circuit here. And what that is if you have a power on reset circuit at pin 4, you can turn on the power and the output will stay in a known state. Sometimes if you don't have this here and you leave pin 4 connected directly to 5 volts, you're going to have some wonky output states. So what I suggest doing is putting a 10K ohm resistor in series with a 100 microfarad capacitor connected to ground. Remember, our electrolytic capacitors have a short lead and a long lead. Our positive lead is our long lead. Our short lead, which is connected to ground, is our shorter lead, or negative lead. So 5 volts connected to a 10K connected to a 100 microfarad electrolytic capacitor connected to pin 4. So what that'll do is when you power it up, your voltage will take some time to go from 0 to 5 volts on a curve, as opposing to going straight to 5 volts. And so basically you power it on, it gives the 555 timer a second to become powered up properly. Okay, going on up here. Pin 5, you can put a 100 nanofarad capacitor between pin 5 and ground, but for this application it's not necessary, so just leave pin 5 alone. Don't touch pin 5. Pin 6 and pin 7. What you want to do is use a jumper and connect them together. So as you can see, pin 7 is connected to pin 6. We've also got our R and C value. This will determine our pulse width at the output. I've got 10K connected to the pins 6 and 7 that are connected, and a another 100 microfarad electrolytic capacitor. Same as our power on reset connected to the connected pins 6 and 7. And what this will do is this will determine our pulse width every time a pulse hits our trigger transistor. So the value, or the formula here is 1.1 times R times C. So 1.1 times 10,000 times 0.0001 gives us roughly 1.1 seconds. So you can fiddle around. You can put a different value for R. You can put a 1K. You can put 100K. For C, you can put 10 micro. You can put 500 micro. You can put 0.1 micro. As long as you follow this very easy formula, you'll be able to determine how long your output pulse is. Now, pin 8 is your VCC pin, connected to 5 volts. Now, you don't have to use the 2N2222. You can use another transistor as long as you're familiar with it. You can use a 2N4401 if you want. They're very cheap, very easy to find. Any of this stuff can be found at your local Radio Shack. So, let's build it up. What I've done is I have taken the output of my comparator, pin 1, connected it to the base of the transistor through a 2K ohm resistor. Now it might be difficult for you to see, but I've actually connected it to pin 2. Now the transistor has a curved side and a front side. From the front side with the writing on it, pin 2 is the base, so the middle pin. So now I've actually placed my 555 timer here with the left notch, with the notch facing left. And what I'm going to do is I'm going to, first of all, I'm going to worry about my transistor. The base is the first pin, or sorry, the emitter is the first pin. So I'm going to take that, pin 1, and connect it to ground, which is my ground line right here. I'm going to take another wire and connect it to connect the collector, which is pin 3, to pin 2. Now, what I also have to do here is I have to remember that I've got a pull-up resistor. So I'm going to get another 2K ohm resistor. I'm going to put it in pin 2. And I'm going to connect it to the 5 volt line. There we go. So, I know it might be a little bit blurry. Sorry about that. I'm going to take another wire and I'm going to connect pin 1 to ground. Again, it helps if you watch the first video. Pin 8, the top left pin, I'm going to connect to 5 volts. I'm going to connect pins 6 and 7 together, just using a little itty bitty piece of resistor wire. Just because you don't really want to make your circuit all that messy. I'm making it a little bit messy just so that you guys can follow along with it. I mean, so now I've made the connection between pin 6 and 7. Now I need the 10K ohm resistor and the 0.1 microfarad capacitor. So I actually have that right here. I'm going to connect one end to the 5 volt line, one end to either pin 6 or 7, it doesn't matter because they are connected. And I'm going to take a 100 microfarad electrolytic capacitor with a short lead and a long lead, and I'm actually, just for the time being, going to put the long lead, which is our positive lead, on pin 6 or 7, doesn't matter which. And because my leads aren't long enough to bring it to the ground line, I'm just going to leave it there right now. I'm going to take a wire and I'm going to connect it here in just 1 second. But now I'm also on pin 4. Remember pin 4, our power and reset circuit? I'm going to take another 10K ohm resistor between 5 volts. I'm just going to use pin 8, which is connected to 5 volts, and connect it to pin 4. And then I'm going to use the other 100 microfarad electrolytic capacitor, put the positive lead, the long lead, in pin 4, and I'll just share that same area of breadboard that's being used by the other negative of the first 100 microfarad electrolytic capacitor, and I'll just use one wire to connect both of the negative leads here and here to the ground line. Last but not least, we're just going to take we're going to connect our 470 ohm resistor and LED to pin 3. It's getting a little bit hectic in here. And then we're going to connect the LED to the ground line. So now I'm going to get it set up for test. So I've got my laser pointer on my LDR. Will it work the first time? I'll power it up. Breach the laser. It works. 1.1 seconds. 1 Mississippi. There you go. Very easy to do. Now, just to give you another example, we used our formula 1.1 times R times C for 1.1 times resistor value times capacitor value. So 1.1 times 10,000 times 0.0001. And that gives us 1.1 seconds. But say we want a longer one. Let me just dig around and find another capacitor, and we'll see if we can lengthen this pulse width. Because I'm short on larger capacitors, what I just did was I put 3 100 microfarad capacitors in parallel. And if you put capacitors in parallel, you add the values together. So we went from 100 microfarad to 300 microfarad. So we're going to bring it up to more than 3 seconds. So let me just turn it on. Pulse. 2, 3. There you go. So that's a long pulse. Now I can put a buzzer there, as we saw at the beginning of the video. You don't have to, just a thought. Now my third video, this one's a bit shorter. My third video, I'm going to show you how to activate a loud siren, or activate a relay that activates a loud siren. This will be a lot of fun. I'm going to show you how to make this into a security system kit. Now, if you can find sirens all over the place, EngineeringShock.com has them, electroniclessons.com has them. Obviously, they can be found on eBay or at other stores. Really, all of these passive components can be found at Radio Shack, but I do encourage you to support your smaller electronic companies if you can. But again, these can be found at Radio Shack, same with the relays in the next video. So again, I'm going to leave this circuit as is, and I'm going to use a relay board in the next video and a siren, and we're going to make a real laser security system out of this. So thanks for watching. If you haven't seen the first video, make sure to watch it. Visit my channel, Patrick Ickes, and if you like this, please like and subscribe. Check out the third video.